short video about a problem that I've been having difficulty solving. What I've done, I've listed 3 things that I need to look up in the book: transpose, cofactors and adjugate. This is in Reza's book, and the problem what I've been doing a lot of work on this one, and I'm not getting it right. So what I've done, I've gone down it and then I've highlighted everything in yellow so that I can go back to it. I know from looking at the book my answer just isn't correct, so therefore I'm doing something wrong. I'm not sure what I'm doing wrong, but this is my strategy for working it out. What I've done, I've written the nature of the problem and the steps to it. So the problem's diagonalisation. I get a matrix A, and then I subtract lambda I, where I is the identity matrix for multiplication. Then I end up with A minus lambda, D minus lambda, B and C there. So I then work out the determinant AD minus BC, so that's that type minus those two. Then I need the quadratic equation formula, which is minus b plus minus root b squared minus 4ac divided by 2a. This is to find the values for lambda 1 and lambda 2, so I can fill them into that. So then I solve the matrix for lambda 1 and lambda 2, so 2 separate matrices now, and then I write down the values for the equations a minus lambda 1x, which will be this line of the equation. It doesn't matter, I can take either line, and then by elimination I write either x in terms of y or y in terms of x. I solve this for both lambda 1 and lambda 2. Then I write, when I've solved lambda 1 and lambda 2, I then work out the vectors from the elimination I've done on that step, and then vector 1 goes x, y vertically like that, vector 2 goes x, y vertically like that. That gives me what is called the P matrix. So then I get a procedure for working out P to the minus 1. So I find the determinant AD minus BC, which will be the same shape as the original matrix. Then I take them from the P matrix. Then I work out 1 divided by AD minus BC times D A minus B minus C. So this is the step that gives me the P to the minus 1 matrix. So from that, I showed you earlier, I need to transpose the cofactors and the adjugate to understand the steps, to understand why we arrive at that. Once I work out the P matrix, I now have a formula: P to the minus 1 multiplied by A multiplied by P, and the order I do it in is P times A times P, with the P on the right side, the A on the left side, because it's non-commutative. And when I find the results of that, I then multiply them by P to the minus 1. That gives me the diagonalised matrix. The diagonalised matrix is for eigenvectors, and the lines associated. Eigen means equal. So these are used in order to simplify the matrices, to make it so that you multiply the x and y vectors by one number each, and then you arrive at, you can reverse this by P to the D diagonalised matrix times P to the minus 1, and then multiply the result of that by P, and then that will give you A, which is the original matrix. So what I've done, although I can't solve the question, I've written down all the steps that I've learned and the places I need to refer to. So what I'm making on these is mathematical errors, Well, what I've done, I've stopped this question, and now I'm going over to another book, which is, I don't know if you can read that, that's Elementary Vector Algebra by Weatherburn, which is the next book I've got, and this is an older book that I've got, and it goes further in the study of the matrix than Rez's book. So I've taken a break from the problem that I've tried a number of times to solve, and I'm going on to study other things, so later on I might come back to it, but I've got all the steps that I needed there, and this is a video showing you this is how I approach mathematics. It's not the neat little solve this, do this, do this, do this videos that you see on mathematics on YouTube. This is going through and struggling with the steps and showing you how I'm struggling and how I'm trying to work things out from that. I hope you find this interesting, because I know maths is not necessarily an exciting topic. So, cheerio.